This is a re-recording of the January 27th lecture, which did not record properly in the lecture hall. Today we're working through the Introduction to Bash Scripting notebook. A bash script is just a plain text file containing a sequence of bash commands. When the script is run, the shell reads the file and uses bash to interpret the commands contained in the script. And so in other words, the script is just a sequence of bash commands, much like a Python program can be a sequence of Python commands or Python statements. So the shell reads the commands one line at a time and executes each line as it reads it. In order to run a file in order to run a script, the file containing the script must be readable and executable to the user. And the operating system needs to know where the script is located. So inside the notebook directories, where the scripts are located for this notebook, if we look inside that directory, we can see that all of the scripts have execute permission for all users, in fact, which is why they show up in green on my terminal. And so this means that we can actually run one of these commands. So if you try to type in one of these commands, so let's try to type in the hello.sh command. You'll see that even though the file is executable, the shell refuses to run the command. It says it doesn't know where this command is. And the reason that's the case is because the shell looks in certain directories for executable commands. So those directories are stored in a variable called path, which is in all uppercase. So if I print out the path variable for my computer, you see that you get this long list of directories. So the absolute paths of the directories are separated by a colon. So we have the directory home CISC220.local bin. Then I've got home CISC220, oh, I have that again. I've got user local sbin, and so on and so on and so on. When you type in a command, bash will look in each one of these directories to find the command. If it doesn't find the command in one of those directories, you end up with the command not found error. Now, notice if you took the time to read this list of paths, you would see that the directory, well, that directory right there is not on the path. So even though we're in the directory containing the hello.sh script, bash still can't find that file. In order to run the script, you have to tell bash what directory is the script located in. So the easiest way to do that, if you're in the directory already, is just to type dot slash. Right? So remember, the dot means the current directory. And now if you type in hello.sh, bash knows where to look for that command, and we end up printing hello world. Right? So in order for in order for you to run a script as a command, the script must be readable, it must be executable to the user, and you need to tell bash, or you need to tell the shell where to find the script file. So scripts are just plain text files. So let's look at that let's look at the hello.sh file. And so that's the contents of the script hello.sh. There's this line here, which I'll explain shortly. And then there's just a command. So that's the echo command that's used to print the string hello world. So your shell scripts are just plain text files that contain a sequence of bash statements. Now, there's no universally accepted style rules for naming your scripts. In this course, I'm always going to use the following conventions. So let's just look at the scripts that are here. So I'm always going to name my shell scripts with the extension .sh. I'm going to use lowercase for the names. If there are, if a if there are more than one word, if there's more than one word in a shell script name, then I'll either just write it out as all one word, or sometimes I might put in an underscore to separate the two words. Here I've actually got a hyphen, which you probably shouldn't do, but it looks like I've got a file called param-sub here. So normally I would avoid using a hyphen in a file name. Right? So generally you want to avoid any special characters. So rather than running the scripts in the notebook, I'm actually going to run them in the terminal. But if you're following along in the notebooks, feel free to just run them in the notebooks. There's the hello.sh script that we just ran. Now, if you wanted to create this script, then all you do is you just open up a text editor and make your script file. So for example, I've got Visual Studio Code here. You can use whatever editor you want. Right? And so here's my script, hello.sh. So let's make a new script. So I'm just going to do a new file. And now you just start typing. So the first line of your script is always, or should always be the following. So the hashtag or the pound symbol followed by an exclamation mark. Sorry, just like followed by the exclamation mark. And then no space, followed by root bin bash. So in Linux, root bin bash is the location of the bash executable program. The hashtag exclamation mark, when that appears on the first line of a file, the script will interpret that, the hashtag exclamation mark, as meaning use whatever follows the hashtag exclamation mark as the interpreter for the rest of this script. So whatever lines of code that follow the first line, these will be interpreted using bash as the interpreter. Now on Mac, if you use root bin bash, then that will be the old version of bash. And you want to use the newer version of bash that you got when you installed I forget what it's called, when you installed the core software. So if you're a Mac user, you can type in the following. So use user bin and then env space bash. So the env command is a command that you can use to look for the bash interpreter on your system. So on your Mac system, assuming you configured it the way that we described to you in the course instructions, it will actually find the newer version of bash that you've installed. On Linux, this also works. So on most Linux systems, you can use this as your first line, and that will also work. Okay, so inside the script, it's just a sequence of bash commands. So here we're just going to, let's just print something out. So this is a script. Right. So there's our script. You want to save the script. So I'm just going to call this new script or something like that. So new script.sh. So there's our script file. If we do the long listing of the directory or of the shell script, you see that we don't have execute permission. So the next thing you would do is you would change the permissions of the file so that we have execute permission. So remember, the command is change mod, and then I'm going to add execute permission for the current user. Right. And now you can see that I now have execute permission on that file. So now I can run that script by typing in // and then the name of the script. Right. And now it runs. So that's the steps you would normally take to create a script file. Now, as I mentioned, the first line of the script always starts with the pound sign followed by the exclamation mark. So that's called the hashbang or shebang. So that set of characters on the first line of a file. If that appears in the first line of a file in a Unix-like environment, then the remainder of the first line of the script is treated as an interpreter directive. So the rest of the line tells the shell what interpreter to use to interpret the rest of the script. So we can create a Python script that uses Python to interpret the contents of the script file. So if we make a new file and we write in the hash bang, followed by the location of Python on my computer. So I believe that's user bin python3. Now I can put some Python code in this script. So for example, we can print hello world. And so this will be hello.py. And now if we go to our terminal, I'm going to give myself execute permission on that file. Or I'll give everybody execute permission on that file. And now we can run hello.py as though it were a command. Right? And we get hello world. But this is using Python as the interpreter instead of bash. There's another way to run a script, even if you don't have execute permission on the script file, and so that's to invoke bash directly. So if you were to type in bash followed by the name of the script, then that will run the contents of the script using bash as the interpreter. So any commands that you would enter at the command line, they can appear in a script. So for example, we can use the fortune program to generate a random fortune, pipe its outputs to the cowsave program, this time using a moose. And if we run that script there, that would run that command, would run this pipeline. So there's fortune cow. So I already have execute permission on the fortune cow .sh file, so I can run that directly like that. Okay, so the following script actually does something somewhat useful. So the following script uses echo to print our hashbangs /bin/bash to standard output. And then we redirect that to a file called temp.sh. And then we use the changemod command to give ourselves execute permission on that file. So what this does is it creates an empty shell script file. It puts in the first line of the file for us, and it changes the permissions of the file so that they're set correctly so that we can run it as a command. So if we run that command, sorry, it's called make sh. So you'll see that there's a script called temp.sh now, and I have execute permission on it. And it has the hashbang bin bash statement on the first line for us. So that creates an empty shell script for us that we can now edit and rename later on. The hashtag symbol or the pound symbol is used to indicate the start of a line-ending comment in bash. So that's similar to Python's comment. The shell will ignore everything after the hashtag. So that's a comment there, and that's a comment there. This script here is called comment.sh, and so this script here appears to do basically nothing. It does, in fact, do almost nothing. So here's our script, comment.sh. If we run the script, not surprisingly, there's no output. But the script does, in fact, do something. So every command in bash sets what's called the exit status, which is an integer value it's a integer value that's 0 or the exit status is an integer value between 0 and 255. An exit status of 0 means that the command executed successfully and encountered no errors. Any value between 1 and 255 indicates that the command encountered some kind of error. There's no particular meaning for, there's no particular error corresponding to each exit value. And so it's up to the command to decide what it sets the exit value to if it encounters certain kinds of errors. You can, the user or another script can query the exit status of the most recently run command. So the most recently run command in this terminal here was the comment.sh command. If I want its exit status, then its exit status is stored in the parameter called question mark. So to get the value stored in question mark, you use $ then question mark. And you can see that the exit status for the comment.sh command was 0, indicating that this command ran and encountered no errors. Comments are allowed to appear after some other command, right? So just like in Python or in Java, everything after the comment start is ignored. If you quote or try to escape the hashtag character, then that does not mark a comment. Right? So this hashtag appears inside of quotes, therefore it's not a comment. So if you actually ran this command, it would actually print, this is not a comment, with the hashtag symbol in front. A comment always terminates a line. Therefore, it's not possible to insert a comment into the middle of a line like you can with Java's /* or / style of comment. So in this script called badcomment.sh, it looks like the programmer is trying to list all of the files that end in .txt, and they've tried to comment out some other stuff here. So they've tried to comment out this list all .txt files line here. Right? The way Bash interprets this is it's ls, then there's a comment. So all of this is ignored. Right? So instead of listing all the files that end in .txt, what ends up happening is, actually this lists all the files, there should be a star here. Should be a star here. And so what ends up happening here is all that happens is the ls command runs. So if we run, oh, sorry, I don't have execute permission on this file. And so if you run that script, all that happens is that ls runs and we list all of the files in the directory. So as we've already seen, most commands accept or require some external information in the form of command line arguments. Right? So either options or actual arguments to the command. Your shell scripts can make use of command line arguments, and the way that they are passed to the script is through these parameters called the positional parameters. So the number of command line arguments is stored in a parameter called hashtag. The individual command line arguments are stored in the shell parameters called 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. So here we've got a little script called viewArgs, which views the command line arguments. All this script does is it prints the number of arguments, right? So the number of arguments is in the parameter hashtag. To get the value of that, we use $hashtag. It then prints out the positional parameter 0, right? So the value of $0 is, sorry, the value stored in 0 we access using $0. It then prints out the command line argument stored in 1, right? So that's $1, and 2, which is $2, and so on, up to 10, which is written as $brace 10. The positional parameters 0 through 9, you can just use the, I guess the symbol or the digit 0 through 9. If you have more than 9 command line parameters, or command line arguments, sorry, then to get to them, you have to put the number inside of braces. Right? So 11 would also be $brace 11 brace. We can't run this particular script effectively inside of Jupyter because there's no way to pass command line arguments to a script from a Jupyter cell. So instead, we're going to have to run this in the terminal. So let's just run the view args script. So if I run view args with no command line arguments, it prints the following. It says there's no arguments. Right? It says that whatever is stored in the parameter 0, well, it looks like it's how I ran the script, and that's in fact what it is. Right? So the value stored in the parameter 0 is the string corresponding to how the script was run. Right? How did I run the script? Well, I typed in .viewArgs.sh. So that's stored in the special parameter 0. So this is one way that you can get the name of the script from inside the script itself. Notice that the script actually does print out everything else that's in the script. So so what I mean by that is, let's just look at the script. Right. So when we use the echo command to print out all of this information, it actually does run this line, and then this line, and this line, and so on, right? Even though there's no command line argument, right? And this line runs, and it runs without error, right? So I can look at the exit status of the script, for example, right, which is 0. So this script did not encounter any errors. Similarly, it actually did try to access the value that's stored in this parameter 2 and 3 and 4 and so on and so forth, right? Even though we didn't supply those command line arguments. It turns out that the values when it prints the value for stored in special parameter 1, it ends up printing the empty string. Similarly here and here and here and so on and so on and so forth. Oh, let's run the script, this time actually passing in some command line arguments. So let's pass in one command line argument, so the string ABC. Right? Now you can see that the value stored in parameter 1 is the string ABC. Right? If you pass in 2 command line arguments, right, then the second command line argument is stored in the special parameter 2. Right? One more time. Right? The third command line argument is stored in the parameter number 3. If you quote your command line argument, ABC, DEF, GHI, right? Well, that's just one command line argument because it's a quoted string. So the shell does not perform word splitting on the quoted string. So it treats it all as one string, and that becomes your that is stored in the special parameter 1. If you type in lots of command line arguments, C, D, E, F, G, H, J, K, L. So many command line arguments, more than 10. Right? All of my command line arguments are stored in the parameters 1 through 10. Right? The K, the L, and the M, they are passed to the script, but they aren't used by the script because they're not accessed, right? So we're not accessing special parameter 11 or 12 or 13. So they don't get printed, but the shell does receive them as arguments. Now that we have, or now that we know how to use the command line arguments, we can go ahead and modify some of our previous scripts so that they do something a little more interesting. So we can change our hello script so that it actually prints out, or it greets the user if we pass in a command line argument. So let's, sorry, wrong scroll bar here. So if we open up the script hello you, right? So this script here expects one command line argument and then prints the string hello. That's called a parameter substitution. So whatever the value of $1 is will get substituted for the $1. So in other words, the value of the first command line argument will replace the $1 in this case here. So if we run that script passing in a command line argument, so let's do CISC220, then it'll print hello CISC220. If you run the script passing in more than one command line argument, so let's do CISC and then 220, right? It ignores the second command line argument. If you don't pass in enough command line arguments, the script still runs, and the value of $1 is just the empty string, right? So this just gets replaced with the empty string now. No error. So there's no, the shell does, or the script does not indicate that it's expecting or requires a command line argument. Right? I'll show you how to deal with that in a few minutes. Okay, so that make shell program command that we wrote that creates a empty shell script called temp.sh and then sets the permissions on that file. Is handy for creating a shell script, an empty shell script that you can fill in, but it would be more useful if it actually created a script that had a name that you could that the user could specify. So we can easily fix this or easily change this program so that it has or requires a command line argument. So that's the named sh script, right? So all we do is change temp.sh to $1 in this case. Right? And so whatever the value of the first command line parameter is, it will get substituted for $1. So here and in the second location there. Right? So for example, if I was to say dot named sh or dot named sh.sh and then my script, we would end up creating a file called my script where it contains that as its first line, and it's the user will have execute permission on that file. So this is .name. Let's call it my script.sh, right? Press enter, and there's my script.sh. If I look at the contents of my script.sh, it's got the one line containing the hashbang bin bash directive. Now, what happens if you run this script and you run the named shell script without passing in command line arguments? Let's see what happens there. Right, so now there's no command line argument, and now you end up with an error. Right. So the first error you get says that that's an ambiguous redirect. So we're redirecting the output of echo to nowhere, right? Because we didn't pass in the command line argument, so that's the empty string. So in bash, that's an error. And then it tries to run the next line, right? And it says that for the change mod command, you're missing the name of the file after the permissions, right? Again, because this is the empty string. So what you really want to do in these two scripts, the hello you and the name shell scripts, are you want to check the number of command line parameters. And so for that, we need a conditional statement, an if statement. So let's go ahead and fix both of these. Oh, there's one more thing. Let's do one more thing with the named shell. So what happens if I run named shell, and this time I pass in the name of a script, but the name of the script has either a special character in it or a space or something like that. So I want to make my space script.sh, right? So there's actually a space here, right there, right? What happens when I run that? So it runs, and there doesn't seem to be an error, but the name of the script is called my, right? It's not my space script.sh, right? And so that's not surprising because we know that bash is doing word splitting here, right? We're actually passing 2 command line arguments to the script. So what happens if I quote it? Right? So now it passes the single string my space script.sh to the script. Right? So let's see what happens now. And again, we end up with this funny error. Right? It says on line 5, there's an ambiguous redirect. Right? And it also says that we cannot access script.sh, no such file or directory, which is strange. Right? Which is quite odd. Okay, so what's happening here is that the value of $1 is being used. Right? Now, remember what the value of $1 is when we pass it in my space script.sh. Right? So the string is quoted, so $1 is in fact the string my script.sh. Right? It's not the quoted string my script.sh, right? It's just the string my space script.sh. So here we're asking the shell to redirect the contents to a file called my, but then there's another argument after that, right? And so that's what this is complaining about here, right? So this redirect, again, is incorrect, right? And now we've got this funny error in change mod, right? So the same thing is happening here. The value of $1 is my space script.sh, right? So there is a file called my in my directory because I created that the last time I ran this command, but there's no file called script.sh. So change mod complains it can't find the file script.sh to change the permissions of. So the error in this case is because we wrote that and that. Right? In both of these cases, the value stored in the positional parameter 1 contains a special character, right? Namely the space. So I have to suppress word breaking or word splitting, sorry, when I substitute the value of whatever is stored in the positional parameter 1. And you do that by quoting or double quoting the access of the variable. Right? So we have to quote the dereferencing of the value that's stored in the variable 1. Right? So if we do that, then this now works. Right? And you now see that there is in fact a script called my space script.sh. So when you're using a variable, or when you're accessing the value of a variable, and that variable might have special characters in it, like spaces or the star or the question mark, then you have to quote it, especially if it's a file name and you're trying to do something like redirect output of a command to that file. Right? Otherwise, word splitting or some other type of parameter some other type of substitution will happen, and whatever that value is after the substitution won't be the one that you're expecting it to be. Okay, so now let's fix the number of command line issue error. So for this script, this script requires exactly 1 command line argument, 1 or more. We can just ignore the excess ones after the first command line argument. So what we really want to do here is insert an if statement that looks at, or it tests the number of command line arguments. If it's less than 1, we want to print an error message. So what we need here is an if statement. So in bash, the if statement looks as the if statement that you can use to test the number of command line arguments looks as follows. So it's if, then a space, 2 round brackets. And now you want to get the number of command line arguments. So that's $#. And I want to check to make sure that that value sorry, I want to check if that value is less than 1 or equal to 0. So let's do equal 0. Right? So in other words, if there are no command line arguments, right, you now have a choice of how you write your if statement. So you can either write it like this, right? So the if statement ends with phi, right? This is on line 6 will be the body of the if statement. If you want the then to appear on the same line as the if, then it's semicolon then, right? If you want to put the then on the next line, you don't need the semicolon, so you can write it like that. Either one is fine. I tend to write it like that. So either way is fine. The body of the if statement should be indented. So in this case here, if the number of command line arguments is 0, there's an error. So I want to print an error message to the user. Right? So I'm going to use echo to print the error message. Right? Now normally, if it's an error in the way that the user has called the script, you would print out a usage message. Right? So this is the way you're supposed to use the script. Right? So it'd be named sh.sh followed by the name of the script. So your script's name, like that. Right? So that will print the error message to standard output. Normally you want to print the error messages to standard error. So the way to print an error message to standard output, to standard error, is to redirect standard error to standard output. The syntax for doing that is as follows. So it's $and2. Right? You can put a 1 here if you like. Right? So remember 1, that's the file descriptor for standard output. If you don't include the 1 and you're redirecting output, then it defaults to standard output. Right? The and2 means copy standard output onto standard error. Right? Number 2 is the standard error file descriptor. So the syntax greater than and 2, copy standard output to standard error. Right? And so that will send the output to standard error instead. Finally, you want to, in this case, we probably want to exit the script because I can't run these 2 lines without a file name. Right? So here we would exit, right? And when we exit, we want to exit with a non-zero exit status. So here I'm just going to pick 1 to exit with. Right? So exit 1 will stop the script and set the exit status of the script to 1. Right? If this if statement isn't true, these lines will run here. So if we save that and run that script, right? So let's do named shell and no command line arguments. Right? There's our error message. Right? If we look at the exit status, we see that the exit status is 1. And so that's an example of how to test the number of command line arguments using an if statement, and then exiting the script if we can't do anything useful without the missing command line argument. I should mention here that if you're using when you use the double round bracket as a condition for an if statement, then whatever is in here must be an arithmetic comparison. So in this case, you can test if the number of command line arguments is equal to 0. If you want to do something else, like compare 2 strings or test if a file is readable or something like that, you cannot use the double round brackets. You have to do something else. But we'll talk about how to write those types of if statements in a future lecture. I guess we can change the hello you script while we're here. Right, so this script also, this particular line only makes sense if there actually is a command line argument. So let's test the number of command line arguments, right? So if $number is equal to 0, then. All right, so here I'm going to do something slightly different. Right. So for this script here, I'm going to say name equals $1. And now here, so I'm going to create a variable called name. I'm going to set the value of name to whatever is in the first positional parameter, right? And then inside the if statement, right, if the command line argument is missing, I'm going to set name to something else. So I'll set name to user. Right? And down here, I'm going to change the 1 to name. Right? And so now this will, if the command line argument is supplied, if at least one command line argument is supplied, name will be set to the first command line argument. If there are no command line arguments, then name will be set to user. And then whatever the value of name is will be used when we print the greeting. So here would be hello you. Hello you. So CISC220. So that works just the same as before. No command line arguments. It's now going to print hello user. Right. So there's an example of where the script doesn't exit with an error. It instead sets the value of a variable to some default value. All right. What else here? Oh, there's one other thing here. I guess I should mention. When you are assigning the value of a variable to another variable, right? You do not have to quote that variable, right? So you don't have to quote the $1 in this case, right? In this case, so even if the positional parameter 1 is holding a string that has some unusual characters in it, there's no need to quote it in order to preserve its value. All right, so that's the end of this lecture. So in the next lecture, we're going to look at using variables in more depth. So when you use a variable, that's called parameter substitution. And there's lots of things that you can do when you perform a parameter substitution.